All right, I want to go over the basics of the DVA Composer software. That's going to be for anyone who owns the DB Technologies DVA T-Series or DVA Mini Series of line arrays and subs. This software is a must-have to help you calculate and predict your fly angles and your sub configurations. Now, once you download the software, you're going to want to go in and either select metric or feet. You'll want to probably have your tooltips on. It'll give you tips and hints as you navigate the program, and of course, select your language. You'll notice that there's 4 main screens: the Composer screen where you do all of your setup, the Line Array Predict screen where you can get the data that you need or alter that data. Same thing with the sub area. And then once we have data entered in, the Print tab will be available and you can print out all the data to take out onto a gig and have a hard copy so that you won't need the computer. All right, so the first thing we do in the Composer window is select which series we're going to be using. In our case, we're going to use T12, T8, and S30. Once we select that, we're going to tell the computer if we're going to fly it or go ground stack. Our example will go with a flown system. And the 3 most important parameters, of course, is going to be your fly height, your audience coverage start and stop point. And with that, it'll give the computer system everything that it needs to calculate all the angles for your system. Now, for graphical representation in the program, you can add your speaker distance gap and your stage settings. So we'll go ahead and do that. And we're going to fly 45 feet and 45 feet apart on our small stage, which is 3 foot high. It's 26 foot wide and 20 foot deep. And we'll either select scaffolding or truss, and we'll have it show us what a truss looks like. Once we have that done, we're going to select the products that we're going to be using for the event. Its total number of fly bars, total number of T12s and T8s, and we can go ahead and pick 8 of our S30 subwoofers. All right, and that's everything that we're going to do here. We're getting some configuration check is okay. That basically means that the speakers that you're using work together. You would have problems if you were to fly T12, T8, and T4. It would give you a negative on that, even though it's physically possible. You're getting a safety check on your flybar. If you were to add 24 T12s to this, you'd get a big error here. It's saying that with the basic settings, you're phase aligned. As you start moving distances from where your subs are, you'll have to check your phase alignment from tops to bottoms. All right, so let's go into the LA Predict window. And this is the basic configuration that it's already calculated for you based on the parameters in the previous screen for a spiral-shaped array. Now, the first thing you want to do is just take a quick look at what J array does. J is going to create a very straight top and curve hard at the bottom. This is going to give you a good compromise on that and give you a little more spread on the bottom. And of course, a spiral is going to give you the most consistent coverage across the near field and the far field. So take a look down here at your SPL plot. I'll zoom in just a bit. All right, and as we change here, you can see the SPL plot sort of change. If we go to the J, we're going to gain quite a bit of SPL in this mid-range section, and it's going to be smoother on the spiral up in the near field. So what's the near field change from spiral to J? And that's because we took a lot of the cabinets that were aimed in this area and moved them to the far field. I always leave spiral as my default. If I want to change anything, I'll do that manually over here in the system data window. And you can change your angle and your EQ preset. And you can experiment with that and watch how it affects your SPL graph. Obviously, what we're trying to do with this is get the most consistent plot from near field to far field. And we're obviously going to expect some roll off here. And in this case, we're dropping off about 7 decibels, which is not bad over 100 feet. And if we wanted that to be more consistent, we'd obviously have to add more boxes. This window here is showing you something that's very important, and DB Technologies software is always going to want to keep your flybar straight or level. And with that, it'll give you what hole you need to put your shackle in to keep that bar straight. If you don't get this right, obviously this is going to tilt, and so will your entire line array tilt, and your aiming is going to be off. There's another window here you can look at, System Detail. It's a close-up of what your boxes are looking like and what the individual angles are. This is telling you that your flybar is going to be at 0, and that's simply a function of where you put your shackle into the pinholes on the bar. and your first angle is 4.5 degrees. And you can see that we've got a straight part. We've got 3 boxes that are all at 0. And to clarify, they're all 0 to each other. This box is at 4.5 degrees, this box is at 4.5 degrees, and this box is at 4.5 degrees. And then from here, we're going to bend back from there at 3 degrees, 3 degrees, and 6 degrees. So this is what you're going to want to print out and take to the gig with you. And the last thing to look at down here is when we're looking at our frequency plot or our SPL plot, it is based on only one frequency. So realize that all boxes have different SPLs at different frequencies. So if we want to throw in 1K versus 2K, we can take a look at that. And we'll see that 1K is going to be a couple dB hotter here at this location. Out here, it's very, very consistent, and we can keep doing that. And you'll also notice that changes with the array shape. So at J, you can again see that we've lost a lot of the high frequency, which is very directional. So keep that in mind. This 2K right here is showing us that when we don't hardly have anything aimed at the 20-foot mark, which is right here, you can tell there's no box, we're not getting any high frequency directivity here. But of course, we've got a lot of our lower frequencies coming in. So we're going to hear 500 just fine right here. So the boxes are playing very well together at the lower frequencies. And as always with all boxes, it's a bit trickier as we go up and are dealing with the high frequency. Now you can also come in and take a look at your plot and save that plot by locking that as you change something. So one thing that I did a lot when I was first buying my system, we bought 8 T12s, and then we bought 8 T8s, and then we bought more T12s. So you're always trying to guess where do you want to go. In order to fill these gaps here and to create a better coverage, you're adding boxes. So let's take a look at a couple options. Let's say that we just have 4 T12s, and this is exactly what I started with, 4 T12s, and we want to see that plot and lock that in. And let's take a look at what happens if we go with 6 T12s per side, or a total of 12, and we can come back now and take a look of what we're getting. So the black line is the original line, and the pink line is the current line. So you can see that we're getting smoother coverage, but we're also getting a good bump in overall decibels. So each line is a 10 dB difference. Again, I'll zoom in, and we're hitting maybe 6 decibels, just because we've got more information now being focused into certain areas. So that's a pretty big deal. And going 5 to 6 decibels and being a bit flatter across the entire range is exactly what we're trying to accomplish with line arrays. So going from 4 to 6 per side is a pretty big deal. You can also do that with your angle. So for example, if I want to look at the J coverage, here's my J coverage, I can lock that in. I can now come over here to spiral coverage, and it'll show me the difference in SPL. So this is a very important feature for you to use as you're experimenting with all the options. That's a basic overview of all 4 of the main window areas in the LA Predict window. The last one is balconies management. That's where you're going to set up, obviously, your balconies and use it to help calculate coverage up in balconies in this area. But it's also used for outdoors if you're in a amphitheater and the first, let's say, 80 feet are flat, and then you've got a rise of your ground going up. You need to put that in so that the system can calculate that. Now, in a future video, we'll go over that in a little more detail, but this is just a basic overview of the Composer software and the Line Array Predict window. If you have any questions, let us know on our YouTube or Facebook pages.